Thank you again. And then we move to our next presentation. Actually, we have heard as advice to touch base, to reach out to scientists who actually got Marie Curie or ERC grants. And here we are with the first one. Dr. Colm O'Rourke is an associate professor of liver genomic and biomarker development at Biotech Research Innovation Center, University of Copenhagen. Since joining the Andersen Group in Denmark in 2015, he has been a postdoc, a Marie Curie postdoctoral fellow and assistant professor. His interests lie in translational omics of gastrointestinal cancer, including patient stratification and therapeutic development. So, Colm, the floor is yours, and thanks for being with us today.
Perfect. Good afternoon, everyone, and thanks to Dr. Gabby and the board of OECI for inviting me here today. It's already been a series of very interesting talks. So as Dr. Gabby introduced, I'm the first non-grant legislator. I am an active cancer researcher today. So what I will go through is, of course, my own personal experience with the Marie Curie individual fellowships. And perhaps I'll give a little bit more applied knowledge to complement Dr. Sorkin's very theoretical breakdown. So as we heard in the first talk from Jan, his #1 piece of advice for young researchers was to move internationally. And for any of you on the call here today who are considering applying for Marie Curie Fellowship, then relocation really is at the heart of what you're going to do. So back in February 2015, I moved from Dublin, Ireland to Copenhagen in Denmark, where I joined the laboratory of Professor Jesper Andersen at BRIC, University of Copenhagen. In September 2015, I submitted the MSCA fellowship application. And by February 2016, the following year, we got the good news back that I had received a positive score for funding. Then we made the decision to actually delay it a little bit. So I actually conducted my fellowship between February 2017 and January 2019. And after completing it, I obviously got quite cozy here in Copenhagen. So I've remained in 2 additional positions. So, of course, the main point of discussion for today is what exactly happened in these 7 months after I arrived in Denmark that led to me actually successfully gaining a Marie Curie fellowship. Well, the answer is quite a lot happened in that time. And first of all, the first thing I had to adapt to was living in a new country, and that included new professional environments as well as new personal situations and a new culture, finding an apartment, etc. So obviously, when I moved here, I had accepted a postdoctoral position from Professor Andersen. That was already a funded grant with a project that was set in stone. So the first thing I did here alongside Professor Andersen was try to reconceptualize a project that was somewhat related to my postdoctoral project, but would better reflect my own personal background in order to submit this for the MSCA fellowship. My next step was then to generate some preliminary data. So I did some in vitro drug screening, and I also performed some genomic analysis of patient tissues, which I ended up eventually using in the actual application itself. Here at University of Copenhagen, they take the Marie Curie applications very seriously as well. So at that time, there was a mandatory 1-day workshop that we had to attend, in which we heard all different kinds of talks from different aspects of the evaluation process. And we actually had to bring some of our writing there for them to give us feedback on. Now, since I did this back in 2015, it's become even more of a large commitment in terms of the duration of the workshop. It is now 2+ days and involves an awful lot of feedback upon writing. After this, I fully drafted the application and I went through several rounds of review by my mentor, Professor Andersen. Here at BRIC, we also have a very active grants office in our administration, and they also very helpfully and very critically dissected what myself and Professor Andersen had come up with. And after multiple rounds of revisions, this is ultimately what I submitted. So this is the application. All of these fellowships have a acronym title. Mine was EpiTargets, and your future projects will need some of these acronyms as well. So essentially what I was working on was epigenome targeted therapy for cholangiocarcinoma. So essentially testing in vitro and in vivo variety of different small molecule inhibitors against epigenetic regulators in biliary tumors. And what everyone gets back, regardless of the outcome from these applications, is a proposal evaluation form in which they break down your overall score, how the score originated, and potential strengths and weaknesses. So, of course, I learned a lot in hindsight from seeing the proposal evaluation form. Now I know what went well. I also know what didn't go so well and what I would change if I had another chance. But hopefully by showing you some of these comments from the evaluation panel on this talk today, we can ensure that you and your future applications will consistently hit the right points that I hit and also avoid the mistakes that I fell into. So as you heard earlier, there are 3 categories for evaluation. These are excellence, impact, and implementation. They do not all carry equal weight. So excellence is 50%, so half of the total score, impact 30%, and implementation 20%. This, of course, should be influential to a certain degree in how much of the 10 pages you actually dedicate to each of these sections. So in my own personal experience, I did dedicate 5 out of 10 pages for excellence, and then approximately 2.5 for the other 2 criteria. And each of these sections is scored by a minimum of 3 evaluators on a range of 0 to 5, going from absolutely does not meet the criterion to excellent overall. And then in sum, your project will be giving a score out of 100. So starting with the excellence section, the first thing that we should point out, based on my own personal experience, as well as trying to support other applicants who came later in a research group, is that the excellence section is typically what us as academic scientists are most comfortable with. So this is essentially the scientific content, merits, and procedures. So what we say and do every day. Overall, I scored a 4.5 out of 5, which is actually the worst scoring of the sections. And underneath this score, I received a long list, as you can see, of strengths and weaknesses. So based upon these comments, I think we can come up with some important tips that anyone online today should follow in their own application. First of all is selling your cancer. So likely all of us on this OECI Academy call are working with cancer in some aspect. And we, of course, all think that our own cancer is the most interesting. So the first thing that we need to convince an evaluator who likely is not working in our own cancer and has likely a very different background to us is why our cancer is so important. So I was and still am predominantly working in cholangiocarcinoma, and clearly the selling point here was that it is 1, a rare cancer, and that 2, we knew little about it. So this is the first thing to think about when you're pitching your proposal. What differentiates your cancer from other cancers that makes your proposal so important? Next, we had to come up with, of course, a question that would be compelling towards an evaluator. And in my case, since I was working on therapeutics, I had a very straightforward one. And that was that for cholangiocarcinoma, there was absolutely no treatments at the time beyond this standard palliative chemotherapy that everyone got for better or for worse. So again, when you're framing your own proposal, do try to think what is the hook for the key question and the key topic in your specific cancer. And lastly, the timing is, of course, important. Thankfully, there are now multiple treatments for cholangiocarcinoma available, so the question I pitched at the time would no longer be viable to pitch today. However, based at the time when I was submitting this around 2015, we saw the first sequencing papers starting to come out, and we found that these tumors, for some reason, had a very high incidence rate of mutations in epigenetic regulators. That, in theory, would suggest that these tumors, distinct from other tumor types, would have a greater sensitivity overall to epigenetic inhibitors. So again, when you're thinking about your proposal, your specific cancer and your specific question, think about what is the main problem here right now at this point in time. So cancer, of course, is a disease that requires interdisciplinary management and interdisciplinary analysis and studying, therefore. And we heard interdisciplinarity as really being a key focus of the MSCA fellowships earlier from Dr. Sorkin. So when you're writing up your project, do try to think in simple terms for a very tired and non-specialist evaluator. Is it clear from your project description what the interdisciplinary aspects are? For example, think about what are the models that you're using, and hopefully this is models plural, not just one. Every model, no matter how good or bad overall, has its strengths, its limitations, and these should be contextualized within your overall study question. We also need to bear in mind that no matter what model we are using, particularly in the research laboratory, how relevant or how similar are they to actually the disease that is manifesting in patients? After selecting your models, we then need to justify the specific techniques that you're using. Again, each of these has their own strengths and limitations that should be contextualized within the specific question at the heart of your proposal. Of course, like all of us, state-of-the-art new technologies are always quite compelling here, so do try to keep in mind whether your technological approaches are keeping up with the state of the art. And if not, is there some way that you can at least incorporate some of these more modern advances into your study design? And lastly here, is this technically feasible? Are you really going to be able to deliver on what you promise? And this could be a reflection of, one, the previous skills based on your background experience that you bring to the new research group. It could be based on the skills of the mentor, the wider institute, or your wider collaborator network. And lastly, of course, a key way to emphasize the feasibility of your project proposal is if you've already generated some preliminary data. So at least my advice would be to try and generate some preliminary data that could build confidence in your technological approach. Of course, what's one of the main tasks that should come out of a Marie Curie fellowship is the acquisition of new knowledge that can then be shared with the wider research community. So earlier we heard about breaking down your specific proposal into individual objectives. Normally for the experimental or research parts, we would advise to have between 2 to 3 objectives, and each of these will be further broken down into individual tasks, with each task having a very clear and simple to understand outcome. We also need a particular action plan because, as we know, science doesn't always go according to plan. All of our objectives should be interrelated, of course. However, all of the objectives should not be interdependent. For example, if objective 1 fails already, can you really proceed to objective 2 or 3? And one of the key ways we go around building confidence again in the organization and the structure of this knowledge development is to have clear risks stated and mitigation strategies that can be put in place if some of these risks end up being true. Lastly, based on our objectives and how we go about them in the action plan, what kind of data are we generating? Are we generating new big molecular data sets? Are we making new biochemical or genetic constructs, developing new cell or mouse-based models? And can we somehow share that ethically according to good practice guidelines with the wider community, thereby extending the access to new knowledge just beyond our own individual research environment? Now, the last one, and arguably my biggest tip out of all of these, is that we really need to demonstrate a clear synergy between what we bring to the table in our new research environment, the capabilities of the new mentor, and the capabilities of the host institution. So no matter our background, we always bring new skill sets, and this should really be shone as brightly as possible in your application. So something based on your background experience should be brought into your new project, and it should play a fundamental role that your mentor or institute would not be able to deliver. Of course, reciprocally, and likely because you joined their lab, your mentor or institute should have some distinct skills that they can now train you in, expanding your skill set. Of course, it's not just this bidirectional interaction. We can and should be building wider collaborator networks, and this is also something to bear in mind, that hopefully we can bounce off our collaborators in order to truly create the synergistic outcome that the EU so desperately wish to foster with these applications. So as I said, I certainly had some weaknesses here, and I think hopefully by dissecting these a little bit here, that some of the people on this call today will not run into similar problems. So the first weakness I was criticized about was the rationale behind some parts of the study design. So I was performing in vitro drug screen using a pre-selected library of epigenetic inhibitors. We did have specific criteria for selection of those drugs that apparently was not clear to the evaluators, because they were essentially asking, why aren't we using some other unspecified drugs? So we think this might have originated from two potential ways. One, I did have quite a general title, so epigenome targeted. Epigenome means different things to different people. So of course, perhaps some of these evaluators had a different perception or knew something we didn't, and then were underwhelmed when we had not covered that based on the drug-based library design. The alternative explanation could be that I had not sufficiently rationalized this in the method section, and it was very easy to miss during the fast evaluation process. Another criticism I received was it was unclear why I would only proceed with in vivo models using one epigenetic target or one epigenetic drug. And of course, here, this is likely a feasibility issue. So for any of us working with in vivo models, we know this takes up quite a lot of time. We only have 2 years for the Marie Curie Fellowship, and if this is coming in the final objective, as it was here, then it's somewhat infeasible to assume that we'd be able to do multiple here at the end of the study. So again, this is the evergreen issue of trying to balance between feasibility and the ambition level of the projects. So important things to bear in mind when you design your own studies, so you don't run into these same traps that I did. So moving from impact or from excellence into impact, impact and implementation are collectively just as important and weighted as importantly as excellence. So this is something to bear in mind. And we also know, based on previous experience, that this is where we as researchers tend to struggle quite a lot. So impact, to give the basic definition, is to have a strong effect on someone or something. So essentially here, what is being asked of us is that if we actually complete our study proposal, what is going to be the overall impact at different levels? And again, here I scored 5, and they listed a bunch of strengths that I will try to really shine a light on so to make sure that your future applications have the same. So the first thing in the pyramid of impacts is that your project will hopefully impact many different levels and many different sectors. We, or you, the future fellows, are at the top of the pyramid. So essentially what this is asking is how will successfully completing your research project improve things or affect your future possibilities. And here the advice we were really given to, that was really given to us during the university workshop, was to spell it out simply for the evaluators. So what I did was I wrote a section literally entitled Impact on Researcher Profile. I broke it down into each of these different headings and gave very clear answers or examples as to how my project would enhance my employability, my translational profile, my leadership skills, my technical expertise, and my fundamental knowledge base. So I would really recommend that you try to do the same and use some of your 10 pages to include these statements and make it easy for the evaluator. Another thing to point out, and what we heard from earlier talks, was the relative importance of collaborating with and or communicating with other non-academic sectors. So I was very surprised here because I just kind of casually mentioned that my mentor, he had previous interactions with industry, and this was sufficient for them to actively comment that the supervisor collaborations with industries are relevant for the project. So if you think that your particular project, no matter how directly or indirectly, might have some opportunity for interaction with industry or other sectors, I would strongly suggest that you write this in the 10 pages. So next on the pyramid for impact is wider healthcare and business sectors. So in the OECI Academy, we were of course all working on cancer, and that means that our work has the potential to influence multiple sectors, again, specifically healthcare and business. So this might be in the form of providing better treatment options for patients, alternative treatment options, development of biomarkers for patient stratification, or simply generating new knowledge that could someday affect healthcare policies. Of course, it might also affect the business sector. And if, for example, we find a novel drug targets, then manufacturing of the small molecule inhibitor or neutralizing antibody would create jobs in the pharma sector, of course. It could also impact healthcare policies, and it could also develop new tools to perform better or optimize our tasks. And then lastly, and the most broad part of the pyramid for impact, is how our projects might affect wider society. So this is really the bigger picture of your research, and it occurs in different flavors that of course you should indicate in this section of your application. So at the professional level, what conferences are you going to go to present your work, and give some clear examples and include them specifically in your Gantt chart, so it's very easy for the evaluator to see. When it comes to publications, can you give, for example, the total number of publications you anticipate from your study, either original research, reviews, meta-analysis, etc., as well as potential and realistic target journals. And of course, here we should also bear in mind the importance of open access during this publication process. Of course, we just don't want to disseminate to other scientists in our field. We also want to disseminate to wider society. And of course, you must, during the conduction of these fellowships, complete multiple lay dissemination events. So this could be the most broadly used, which is National Science Day participation. It happens in every country and it's very easy and enjoyable to participate in. You could do what we did here, which was actually to organize new workshops, teaching either students or teachers new things, in my case about genomics. And of course, media engagement is always there. So via your institute, can you then communicate your findings to national or international media? One important thing to point out here is to always bear in mind the potential for intellectual property rights. To indicate this in your application, that you'll coordinate with your local tech transfer office, and to give some sort of timeline within your Gantt chart as to when you might anticipate that you should start to consider IPR rights, since this takes quite a large amount of time if you proceed with it. Then the last section is the implementation section, and this is essentially how we get things done, or how likely we are to get things done in an orderly manner. Here, again, I scored 5. And again, they listed various strengths that I hope we can use to focus your future applications. So the first thing here really is that organization is key, and you should really spend time on your Gantt chart. This was actually the first time I ever made a Gantt chart, and it was definitely a baptism by fire. Here you can see a breakdown of the entire 24-month period into 5 different work packages. So work package 1, 2, and 3 refer to the experimental or research objectives. Each of them have specific milestones and deliverables that are colored here and coded here and are described in text and actual application. So these really should be as specific as possible. Work package 4 here specifically referred to training goals. So these were new skills I should learn, new international visits I should participate in, conferences, etc. And then the final work package 5, involved various types of dissemination, exploitation, and public engagement. So please do spend a lot of time on these Gantt charts. Next, management is of course key, and this comes at 3 different levels again. So from your host institute, you will need to obtain information, for example, about the total number of grants they've previously managed, the total number of previous Marie Curie fellows, and whether or not there was previous IP successfully filed by the institute. You also need to indicate to what extent your progress will be monitored, and this could be the frequency of your personal supervisor meetings, the frequency of collaborator meetings, or when you will be expected to give formal presentations in different settings. And lastly, really we need to indicate here your strategy for dealing with the unknown. So as we said previously, every single objective and work package needs to come with multiple risks that should be evaluated at levels of low, medium, or high. And in the event that those risks do indeed occur, rational and understandable contingency plans should be put in place and clearly stated. Then second last is readiness. How ready are you to start your project if all of a sudden you are awarded these fellowships? And this includes various aspects such as your infrastructure. So what core facilities do you have access to that are really fundamental in successfully completing your Marie Curie fellowship? What equipment do you also have access to and or potential training in? What peers are you interacting with? Is there opportunities for them to supervise you whilst using some of these systems? Or is there an opportunity to train you fully so that you can independently use these systems? And then lastly, the resources that are specific to your project. And this could be something as simple in my case as literally already having bought a library of drugs and having them ready to go, having particular cells or mouse models available to you, or having patient biomaterial readily available locally. Lastly, and again, we are harking back to what we saw in the excellence section again, is that they're really looking for a clear synergy between the host institute, the host organization, and the fellow. So I would really urge all of you, with this being the most important aspect, to ask some of your peers to read your draft Marie Curie fellowship application and to ask them if they can really simply list some of the skills that are flowing from you, the fellow, to the mentor, the institute, and vice versa. If they can't easily do this, then if they can't easily do this, then there's an issue with your current version of the grants, and you should revisit this to make this clear. So the very last slide is to give some general tips, and that is, first of all, what you've heard already: preparation is a marathon, not a sprint. Start prep early, ideally more than 3 months beforehand, and ask others outside your field of expertise for their feedback. Use EU language to your advantage. So the Bible that you heard mentioned earlier, look at the very specific language they use and use it in your actual application. Think synergy of the fellow host institute, and don't forget key considerations such as ethics, gender dimension, data sharing, open access, and keep up to date with changing guidelines. And with that, I will say thanks to everyone involved, including OECI, for inviting me, and give best wishes to all of the individual fellows applying this year. Thanks.
Thank you so much, Colm. Wow, it was really comprehensive. So thanks a lot. Please stay with us. We will have a Q&A session after next presentation.